Assalamualaikum. In this video, me and my friends will present about NIDEK MP-3 Microperimeter. NIDEK MP-3 Microperimeter is an optical device designed to perform microperimetry technique, or also known as fundus-related perimetry. This device measures local retinal sensitivity towards the presented stimulus for functional assessment of the retina. It correlates retinal morphology with its function over the color fundus image that it displays. Under a single examination, it collaborates fundus imaging, retinal sensitivity mapping, and also fixation analysis. The key features of NIDEK microperimeter are wide range of stimulus intensity, high-resolution retinal image, auto-tracking and auto-alignment function, and also fixation tests. So microperimetry technique is a fully non-invasive test and is very easy to use for both patient and operator. First, patient needs to place their head on the chin rest and machine will automatically align with the pupil. And then, machine automatically obtain an infrared image of fundus used for tracking during the perimetry exam, and at the end of the exam, it automatically captures a color fundus image to align with the microperimetry. The patient will have to push a trigger button whenever they see a stimulus. And now I will briefly talk about the history of the microperimeter. In the year 1980s, scanning laser ophthalmoscope, or SLO, was invented by Dr. Oleg Pomerantsev and Dr. Charles Shepens with the assistance of PROF. It is a type of manual microperimeter, an instrumentation capable of psychophysical testing in the form of manual stimulus presentation directly onto the retina. The design includes the acousto-optic modulation and addition of computer with graphics imaging capabilities. After that, further refinement has been made involving the tracking of the retinal landmark by the application of automated thresholding procedure in presenting the stimuli.
Now, I will explain about the MP-3 NIDEK optics. First of all, LCD. A stimulus shown on the internal LCD screen is imaged on the retina as light path shown with blue arrow. Then, the retina is illuminated with infrared source. The infrared source will be reflected from the retina and imaged with a camera as light path shown with the red arrows. The lenses, the L1 and L2, are used to form a visual image at the same plane as the LCD.
Now we'll move on to the components of NIDEK MP-3 microperimeter. Okay, here are some of the components of the microperimeter. Firstly, there is the forehead rest, which is to support the patient's head, and the chin rest, which is to support the patient's chin, the canter swab, to ensure accurate positioning of the patient's head, and this is the push button. The button will be pushed when patient sees a stimulus. And here's the joystick, which is a one-handed vertical, horizontal and diagonal adjustment for better viewing of the macula. And here's the touch screen and findings obtained from microperimeter. This is a magnification knob that adjusts magnification of the microperimeter, and the illumination control knob to control the amount of illumination, and the chin rest adjustment buttons to adjust the height of chin rest, and the power switch to turn the microperimeter on or off, and the PC connection port to connect the microperimeter to a PC, like this one. So that's a PC monitor for a better view and analysis of microperimeter findings with a software called Navy's EX Viewer. And that's a fundus camera, which is a CCD camera or a charge coupled device camera for microperimeter imaging. And here's a better view of the chin rest and forehead rest.
Let's talk about the function of MP-3 NIDEK. First, it has auto-tracking and auto-alignment. This can produce more accurate measurements that increase patient and examiner comfort. Second, it has high-resolution fundus camera that allows easy image acquisition. The MP-3 also can conduct fixation tests where it determines the preferred retinal locus by having patient fixed on the target. It can evaluate any fixation in patient with central visual field defects and determine either the fixation is improved or not. The interesting part is this MP-3 can perform follow-up tests on the same area using similar parameters. The operator can evaluate of disease progressions between pre and post-treatment image. If there is any difference between both images, it will display for quick interpretations. Lastly, it has wide range measurements of stimulus intensity from 0 to 34 decibels. This enables measurements of parametric thresholds values even for normal eyes.
Okay, next is the advantage of NIDEK MP3. One of the advantages side by side of any change in sensitivity at each testing point. It allows the examiner to test the effect on macular function over time and makes it quick and easy to see how function may have changed. And then the second one is it has previous patient history, where the device will use the previous exam to auto-align the stimulus point in the same exact test. Third one is it has higher reproducibility, where the measurement of the retinal sensitivity using MP3 was well tolerated in every subject under the study. And then next is it has wider range of stimulus intensity from 0 to 34 dB. And then next is it utilizes an improved motion tracking system and full automatic measurement procedure. Okay, the last one is it has maximum stimulation luminance of 10,000 ASP to allow evaluation of low sensitivity. Okay, we move to the limitations of the NIDEK MP3. The first one is it has smaller field of view, where it limiting the evaluation of posterior pole. And then the second one is it requires at least 4 mm pupil diameter, where the patients need to undergo dilations. Then the last one is it gives impact on treatment decisions. For example, the patient with a long history of diabetes, age-related macular degeneration, unable to undergo fluorescent angiography due to allergy. I think that's all from us. Thank you.